So equation 14-8 gives the heat absorption rate for an object facing the sun. The heat required to melt the ice is the mass of the ice times the latent heat of fusion for the ice. And the mass is found by multiplying the volume of the ice by its density. So we have delta Q here is equal to mass times the latent heat, M L sub F. But mass is equal to rho times the volume, right? But the volume here is the area times delta X, which we know, 0.01 meters. And of course, still multiplied by the latent heat, L sub F, which we also know. Okay, so we don't know A, and we're trying to find delta T, but we know that delta T, or we know that this ratio, delta Q over delta T, is equal to 1,000 watts per meter squared multiplied by epsilon times the area times the cosine of theta. Okay, well then if we go ahead and solve for delta T and use the first expression for delta Q, we'll go ahead and do this on this new page, we find that delta T is equal to rho times the area times delta X times L sub F, because that was Q, divided by the value of delta Q to delta T. Okay, so that was 1,000 watts per meter squared times epsilon times the area times the cosine of the angle theta. Well, the area on the top and the bottom cancel, so we'll just mark that out here in red. And we know everything else in this expression, so we plug all the other values into this expression, and we find that this is equal to 7.5 times 10 to the 4 seconds, which is about 20.7 hours, but we're just going to leave it in seconds and box that in as our solution.